Hi everyone, welcome back to the Painting with Plotters course. This is Module 1, a module that I am so excited about. In this module, we're going to talk about all the machines, materials, and tools you will need in order to make plotter paintings. In this very first video, I'm going to talk about two major topics. First, all the machines you would need in order to make plotter paintings. And second, how to prepare your machines and your painting environment for plotter paintings. Okay, let's get started. To make a plotter painting, you would need a plotter. Some of you might already have one and you're trying to decide whether it would work for the painting process or not. Or you might be looking at the available models and trying to decide which one to buy. Or you might be considering building your own plotters and trying to figure out what kind of design you would have for your plotter so that it could make paintings. So let's talk about several things that I think you should consider when deciding whether a plotter would work for painting or not. First, considering the plotting angle of your plotter and think about how that would impact your paint. There are so many types of plotters. There are plotters that are designed to plot on a horizontal surface. Some of them are designed to plot on vertical surfaces. There are also plotters designed to be plotting on a slanted surface. If you are plotting with a pen or a marker, the plotting angle might not make a huge difference. However, if you're painting, this plotting angle is actually quite important. If you're painting with materials that can flow, such as watercolor, ink, or acrylic, plotting at an angle means that your paint will flow down. That's not to say that vertical or slanted plotter wouldn't be able to paint. You can definitely make paintings with vertical plotters if you're using thicker materials, for instance, oil paint or thick acrylic. Because I only use flat plotters, everything that I show in this course will be about flat plotters. But many of the techniques that I discuss could also be applicable to vertical and slanted plotters. Second, check if your plotter has a paper feeding mechanism. Some of the plotters might have a paper feeding mechanism. For instance, it might have a roller so that you can save a lot of space. You can plot really long images without having a huge footage. However, it might be challenging to paint with this type of plotter. These machines typically move the paper with some kind of tire, and those tires are in constant contact with the paper. So you need to figure out how to avoid smudging your paintings during the process. And also, it might be a challenge to figure out where to put all of those little ink trays. Third, considering whether there's enough space in the Z direction. If you are plotting with a pen or a marker, it's likely that you don't need a huge Z-axis space on your plotter. If you just lift your pen slightly off the page, you would not leave a mark. Many plotters might actually optimize this so that you can plot much faster. However, for plotting with paint, you need to have a much larger Z-axis space so that you can fit all those trays underneath. So if your plotter has extremely limited Z-axis height, that might be a problem. So that's all the criteria that I'd start with if you're making a selection. Now, let's talk about the plotter that I'll be using in this course. I have many plotters, but most of the plotters that I own are AxiDraws. This is a high-precision plotter that checks all of my boxes. It is made by EvoMed Scientist Lab, which recently joined force with Bantam Tools. They have been releasing some new models recently, including this model called NextDraw. I have so many good things to say about AxiDraw. they are reliable, they are really easy to use, and then they come with amazing customer support. I just love this machine, so I keep buying more of it. In my 5 years of plotting so far, I only had one serious issue with AxiDraw, which I'm really happy to say has been fixed by a recent hardware upgrade. My issue with the original AxiDraw is with its servo motor. AxiDraw came with the servo motor called SG90. It is a mini servo motor that is affordable, lightweight, and used in many robotics and DIY projects. If you're using a plotter that is not an AxiDraw, there's still a good chance that you have this motor in your machine. So, this mini servo motor is not the most durable and long-lasting servo motor ever. After a certain number of ups and downs, it will eventually stop working. But because this motor is relatively cheap and easy to swap out, it's normally not a huge issue. I have met several artists who have been using their original servo motor with the AxiDraw for several years without having any issues. However, painting with plotters using my method seems to damage those motors at a crazy speed. I had to replace my motor so many times. I think there are a combination of factors that caused this. To start, painting with plotters means that you are adding a lot more works for your plotters. If you're just drawing a line with your pen or a marker, you would do pen down, draw the line, and then pen up. So it requires you to rotate your motors twice. If you're painting, it means you are adding a lot more steps into the sequence. The second potential cause might be associated with the range of motion required for painting. If you just draw with a pen, you only need to lift the pen slightly off the paper. So it is likely that you're not using the full range of motion provided by your motor. However, my painting method often requires the full Z-axis motion so that I can reach the bottom of the ink trace. Rotating the motor at the full range every time might also wear out the motor faster. Another potential cause I suspect is how long I actually run my plotters continuously. A typical A3 painting of mine would take any time between 12 hours to 24 hours. The motors are constantly running, and running them in such a long session seems to destroy them quickly. So those potential causes are my best guesses. But because I am not an expert in motor design, I cannot confirm whether those are the actual causes. But even if I confirm that those are the actual causes, I don't know what I can do about them. I don't know how to magically reducing my plotter time from 12 hours to, let's say, 30 minutes so that I can save the life of my motor. So I just decided to suffer the consequences of those motor failures. When those motors die, it will typically make a scene. Your pen or brush will drag along your painting surface, kind of destroy your painting, leave unwanted marks, rip your paper. Because you're painting, you have all those ink traces on your surface. You are likely knock into some of the trays, you have a water spill, you have paint splashing everywhere. It's like a crime scene. Because I had broken so many motors and cleaned up so many times, now I am really efficient at swapping out the motors and then protecting everything around the plotter. And you can imagine how happy I was when Evil Mad Scientist Lab came up with a better solution. They released 2 upgrades. The first one is a cordless servo motor. It is very similar to the original version, but much more sturdy. And replacing this motor is quite easy. The second upgrade is the brushless motor. It is more expensive and requires slightly more setup because the motor needs a different voltage, but this is definitely something you can do in under an hour. It is significantly more expensive than the $6 SG90S motor, but in my opinion, it is worth every penny. It is much stronger and much more durable than the original version. With the previous motor, I'd say the longest usage time was probably around 200, definitely under 300 hours. But with the new one, I have been using it for thousands of hours and it hasn't shown any issues so far. So my conclusion is, I'd highly recommend that you get this upgrade if you're getting an AxiDraw. If you're getting NextDraw, which is the upgraded version of AxiDraw, you don't have to worry about this. Just one more thing before we move on to the next part. If you're considering buying a plotter, I'd recommend getting a big one. You see, the painting trays will actually take up a significant space. So if you have an A3 plotter, you can never paint an A3 image. It will be a little smaller. You can always plot smaller images with bigger machines. For instance, like what I'm doing here, I am plotting A6 images with an A3 plotter. So if your space and the budget allow, I'd recommend getting a bigger one so that you have more area to work with. Okay, so now you have a plotter. It's likely that you also need to have a computer to control the plotter. Some of the plotters might come with a computer that you can directly input your data and then plot it. But AxiDraw doesn't, so you would need to have a laptop or a desktop or some type of computer to control it. I'm sure your laptop would work great, but if you have really long plotting sessions like what I have normally with my paintings, it means my computer would have to stay on for that entire period of time. Therefore, I use Raspberry Pis to control my plotters. They are powerful enough to operate the plotter, significantly cheaper than laptops, and they won't consume as much energy as a typical laptop. Previously, I connected a portable monitor to the Raspberry Pi and I just used a USB stick to transform my design. But I have recently switched to a much cleaner way of operating those plotters by setting up a network and controlling all of the Raspberry Pis and plotters remotely. This might be an overkill if you are just operating one machine, but if this is something that you would like to learn more about, please let me know. I might make a video about this in the future. Now you have a plotter and a computer to control the plotter. Let's look at how to prepare your machine and your painting environment. I will share 4 principles that I use in my studio to keep everything safe and working properly. First, nothing can move except for the plotter arm. When you operate the plotter, the first thing you will notice is that you need to fix the paper in place. Otherwise, the friction between the pen and the paper will move the paper. This is true for the ink trays. So you will have to have a mechanism to keep the paper and ink trays in place. I have tried many ways to fix my paper and ink trays, starting with tape, which is the most accessible and easy to use method. The issue is that, well, they look a little too taped together. And every time you take the trays to wash, for instance, you will have to make sure to tape everything back to the exact location. It gets tedious. I would say taping everything together is great when you're getting started and when you're trying different setups. It's a quick way to get everything running. However, once you figure out your ideal setup, I'd recommend moving away from the tapes and move to something that's more stable and more permanent. Since last year, all of my plotters have switched to a magnetic-based plotting environment. The idea is simple. I have a magnetic board under the plotter, and I add magnets to whatever I need to fix. If you have a metal tabletop, that is great, you're ready to go. But if you don't, you can also use magnetic whiteboard. There are a few benefits of using those whiteboards besides being able to stick magnets on them. They are relatively economical and available in various sizes. They are very easy to clean. If they get too dirty, you can paint over them, sand them, do whatever you want, they're still functional. The downside of the whiteboard is that they are not always flat, especially the large ones. My board is 1.2 meters and they are slightly warped. This warping doesn't matter much to me, but just keep in mind that this warping might bring some distortion to your image. Besides having a system to fix your paper and ink trace, it is also very important that you fix your plotter in place. You might think, why is this necessary, right? Your plotter is heavy enough, it doesn't move easily, why do you still have to fix it in place? Well, that's what I thought initially. I don't fix my plotter, it's just like sitting on my table and doing the paintings. It works fine until one day I heard a super loud noise, and guess what? My plotter was on the floor, it just fell on the floor. Turns out the motor had failed, and when it failed, the brush was at a low position, so it knocked into one of the paint trays. And because there's nothing holding the plotter, this force eventually pushed the plotter off the table. Luckily, nothing serious happened. My plotter, Kitty, was still functioning after the fall, but afterwards I always fix my plotter onto the surface so it would never fall off it. How I fix my plotter onto the table also has some connections to the second point that I'm going to make. So let's jump to the second point so that I can show you why I do it this way. Second point, water shouldn't reach electronics. When working with paint and water, it is important to think about the worst case scenario. If all of this water and paint are knocked over and started flowing without any control, where would they go? My top priority is that they should not go into any electronics. To do that, I have a multi-level setup. I raise the plotter up and move the computers and power sources down. When a water spill happens, it will flow across the table, but it will not be able to reach my plotter and computer easily. My table comes with a second level, so moving all of this computer downstairs is easy. I have tried several things to raise the plotter. You can use clamps to fix them in place. Besides this method, I also want to show you a new method I recently developed, which is 3D printing your own base block. Those are my 3D printed base blocks that fit perfectly to the leg of the AxiDraw. Those additional rails serve 3 different purposes. First, I can 3D print my own clamps that will fit perfectly to the rail. Second, these rails can be drilled through easily. Third, I developed a rail extension system so that whatever table situation I have, I can reach to the edge of the table. Another issue that this 3D printed base solves is the Z-axis dropping issue. If you have a bigger one, such as the A1 AxiDraw, you will notice that the Z-axis will drop quite a bit as it moves along the Y-axis. This is basically gravity doing its job. It is a really long and heavy arm, so it drops down as it extends. When I 3D print my plotter base blocks, I can print them slanted so that it would offset the z-axis dropping. We will talk about how to design those 3D models with Python in one of the future videos. But for now, if you just want to try and print your own plotter base, you can go directly to our GitHub repository and the files are there waiting for you. Third principle, be prepared for paint splashing damage. The third principle also seems really obvious, but sometimes I still fail at this. So previously, I told you my story of experiencing many plotter failures which caused lots of water spills and paint splashing. I also want to tell you how much damage they had done to everything around the plotter. The walls are especially difficult to clean. Some of the ink might actually dye the wall permanently. So, this is absolutely true. When I moved out of my previous studio, I didn't get my deposit back. The rental company told me they had to paint the wall twice in order to cover all of the marks that my plotter left. So, let this be a warning. Do be prepared of paint splashing damage and just cover your walls. Buy a really large roll of paper, tape it onto the wall, and then you're prepared. The last principle I'd share is to always double check your machines before you hit running. Before every plotter run, I think it's a best practice to make sure your plotter is in the correct state. There are two specific things that I would look for. First is whether you have returned your AxiDraw, your plotter, to its original home location. The second thing that I'm going to check for is whether I have set my brush at the correct z-axis height. Okay, so in today's video, I have discussed 3 criteria for picking a plotter for painting. We discussed a common issue with plotters, especially with original AxiDraw servo motor. So make sure you check your motor and hope you have a really durable and sturdy motor to play with. We also discussed the 4 principles that I use to prepare my machines and my painting environment to reduce the risk of water, paint, and electricity damage. I hope this information will be helpful to you when you are setting up your own plotter painting environment. In the next part of the module, we're going to talk about materials and tools you will need in order to make plotter paintings. Well, thanks for joining me, and I'll see you in the next one.